Thank you. Welcome back, everyone. Today we're going to talk about arrays, vectors, and strings. How familiar are you guys with the topic? Because I want to see how much time we can delegate for problem solving and teaching. Maybe let's do a poll right now.
Also, maybe we can reintroduce ourselves, since we only quickly got a chance to introduce ourselves during the first session.
Okay, so I'm Katie.
I'm Bill. I'm a ICPC officer, third year CS major.
I'm Anna. I'm also a third year CS major.
And I'm Sarthak, and I'm a second year CS major.
Hi, I'm Arjun. I'm a fourth year CS major, and I'm a Swiftie. So yeah, that's all you need to know about me, to be honest.
Okay, so you guys know what we're gonna talk about today pretty well. So we're gonna spend more time on the problems. Okay, so this is the attendance code for today. I'll give you a minute to do it. Actually, 30 seconds, because you can view it later. Okay, time's up. And this is the link to our slide today. You can scan it or use the QR code, it doesn't matter, or use the link, it doesn't really matter. Okay, so what are arrays? Array is a data structure that stores a fixed size collection of elements of the same data type. This is the case for C++ and Java, but not not necessarily true for other languages. Because say Python does let you store a dynamic size of different data types, but today's focus is on C++, so that doesn't really matter. So given our definition for an array, can you guys tell me which one of the four on the right, on the slide on the right is not an array? Okay, so someone said the first one. So this is tricky because if I have a cat data type, then it's not an, then this is defined as an array because they are the same cats and it's fixed size. Someone said the second one. The second one is because it's all integers / numbers. And someone said the third one. Yes, the third one is good because it's strings. I might get the job. They're all characters, but the first one, but the number one is an integer. It's not quoted. If you look at the fourth one, it's quoted, so you know that it's written as a string, so it's the same data type. Okay. So moving on. The most important thing about arrays is that their elements are stored in contiguous locations and are not particularly ordered. This is important because for other data structures, they're not necessarily ordered. As in, if I put, say, number 7 into my first element in the array, it doesn't change. It stays as the first one. But then for other data structures, that 7 might go to all the other slots. It might not necessarily go stay as the first element. And if you don't know already, array indexes start at 0. And it goes to size n-1. So with that information given, can you tell me the big O for accessing, searching, and inserting and deleting the array? Accessing should be easy because recall that it's stored in contiguous locations. Yes, it is all what? That's good. How about searching? Okay, that's close. Okay, all of them is true. If it's sorted, it should be in log n if I remember correctly, because you still have to go through it. How about for insertion and deletion?
Oh yeah, I think Ben is right here. If it's already sorted, it will only take O of login to search, but like obviously the searching operation is n login. So yeah, you're definitely right on that count.
Thank you, Bill, for the clarification. And yes, for insertion and deletion, it's open. For inserting and deleting at the end, it would be constant, but since we're looking at the worst case, inserting and deleting at the middle or at the front would be O of N. So that's the answer. Okay, so now we're gonna talk about vectors. Vectors are like arrays, but they're dynamic. They can be passed and returned from functions. This is important because for arrays, you can't really pass in or return them. Instead, they're accessed as pointers, and you don't really know their size. So you have to include another parameter to define their size. This might be troublesome because that's more work. And for for vectors, you can use STL functions like begin and end and size. And then you can access it at the front, back, and all that. You have all these cool functions that make your life easier. So this is the big O for vectors. As you can see, they're pretty much the same as arrays. So you might wonder, well, what's the difference? When do I use arrays and when do I use vectors? Well, you can use vectors when you don't really know the size of doing things. So say like, I wanna like build this program and I have like, I wanna use this data structure to store my things, I might use a vector, right? But if say I'm only reading things in and like it's a fixed byte, then I can use arrays because that's faster because I don't really have to, I have a fast memory access because the size is defined. So vectors are usually used in interviews like high 90-something% because of its flexibility. So you don't really have to care about arrays in this course. We'll be focusing on vectors instead. Okay, so that might be a lot of information. Let's take a break for 5 minutes. And after that, we'll be doing problems. Thank you. I love cats too. Yes, the link to the slides are, hold on. The link to the slides are here. Oh, we have 1 hour and 30 minutes. Yes, they are regularly scheduled.
Okay, great. It looks like everyone is back. And from at least what I saw in the breakout rooms, I visited a couple of them. You guys have either thought of like a solution or thought of like the most efficient solution. So I think you guys are super like ahead of the curve, and like if you guys can solve this problem, you guys are already doing really well. And so when coming up with the solution to this problem, when discussing the solution to this problem, I'm gonna focus less on the actual like idea of the solution and more on what you should be doing like during an interview. But nonetheless, let's get started. So as I said before, like the first thing you should be doing during any technical interview is be asking clarifying questions, just to make sure that you understand the problem and you don't run into issue later on in the interview where based on a bad assumption you made, a lot of your code doesn't work or is implemented incorrectly. So like common questions like this could be like, hey, can these prices be negative? Is it like, what happens when you can't achieve any profit, which you return? Now, this question specifies that you should return 0, but they might not tell you that, and you might have to ask about that. You could ask stuff like, is there any bound of how high the price, the number, like the price of the stock can be? Or if there is a guarantee that there are going to be at least 2 prices in the array that the interviewer gives you, right? Because if you don't have 2 prices, then you might not actually be able to like achieve any profit as well. And so make sure you ask these clarifying questions. And let's say the interviewer gives you these answers. So let's say they say, okay, these prices, they can't be negative. They're either 0 or positive. So like, no, none of that oil future negative stock values kind of stuff. And let's say they say that, there is, when you cannot achieve any profit, you should be returning 0. As well as that there's a guarantee that the prices array is always going to have 2 or more elements in it. So you're always guaranteed to have at least 2 prices. And so to get started is you would normally start with just brainstorming. You wouldn't start writing down code. What you try to do is you try to brainstorm and think of a solution. Now, the first solution you think of might not be the best solution. It might be the brute force solution. So let's say you have these 2 like examples here. Let's say this is one of the stock price listings, and this is another. So for this one, the best place to buy would be at this one, and the best place to sell would be at this 6. And therefore, you should be returning a 5. And so maybe the first thing that comes to mind to like solving this problem is, okay, so I can brute force this by looking at every single possible valid set of transactions, every single possible valid set of buys and set of sells. So in that case, you would be, for each price, you would be looking at all future prices and comparing them to see what your profit would be until you've compared all possible profits and then found the max one. Now, a lot of you guys were really smart and realized that this would be a big O of n squared, since you are looping, basically have a nested for loop, and it's not the most efficient solution here. And so maybe you think about this, and maybe the interviewer gives you some hints, and you realize that the better solution, which a lot of you guys did realize, was based on a fact that for every place where you can possibly sell the stock, so for every possible selling index, a lot of you guys noticed that the best place to buy is always going to be the minimum value of all of the elements before the place you want to sell, right? So in that case, you only really have to care about one value every time you consider selling at a certain point, and that's the minimum value that comes before it. This means that you can simply loop through the array once, keeping track of the smallest value you've seen so far, and comparing that with the current value that you're looping for, right? So here, like you would take a look at 7, you can only like buy and sell at 7, so that's 0, but you keep track of 7, and that's the lowest value you've seen. And then you can go to the next number, and 1 is also the lowest value you've seen, so that would be, again, 0 profit. But then you can head to 5, where at 5, 1 is still the lowest number you've seen, but at 5, minus 1 is going to be 4, so that's a profit of 4. And then you can keep moving on, but you only have to keep track of the number 1 because that's going to be the lowest number you see for the rest of the prices. And so eventually when you get to 6, you'll realize that the lowest number you've seen is 1, and then you'll get your maximum profit, which is 5. And so you can do the same thing. This also works here because it'll naturally calculate a profit of 0 when the lowest value you've seen is the current value. So we can get started implementing this. So let's say you are given a vector of prices. What you can do here is first you can define the minimum value you want to keep track of. And because, remember, we heard before from the interviewer that it's guaranteed to have at least 2 values in the prices vector, as well as you can keep track of your current profit, which is going to be 0. And you know that you want to, this is the value you want to return. And so you can make one for loop here. You can start at the first index or the second index, basically, since you've already considered the first index. Down here. Right. And then you can update the min value, which is going to be the minimum value that you've seen so far. So min value and this is I. And you want to update your profit, which is going to be the max profit you've seen so far. That's going to be max profit and your current value minus the minimum value that you've seen so far. And after you've gone through the whole loop like this, you can simply return profit. And that should just work. Now, what's also important during technical interviews is being able to come up with test cases on your own. And so even though you might not naturally think that's part of the problem solving process for technical interviews, it's still super important to be able to come up with test cases because, in industry, engineers are usually also required to write unit tests and regression tests and stuff like that. And so we can write a test case. So first we can write a vector, this one, and we can initialize it to, let's say, these values here. And then what we can do is we can see out the result of our function here with our test case. And this should give us the correct answer, which should be 5 if we run it. And as long as we call this in our main function. So run this and it should print out 5. There we go. So we run it and it does give us the correct solution. And then we can also implement our second test case. And this should give us a result of 0. There we go. And it should give us 5 and then 0 on another line. So to run. And there we go. It gives us 5 and a 0. And so congrats, you guys have kind of tackled your first interview problem and you're now ready to tackle the stock market. But yeah, great. I think I will pass it off to Arjun, who will go over our next problem.
Alrighty, thanks, Bill, for not only showing us that problem, but also educating us on the intricacies of the stock market. So our next problem is sorted to sum. And, oh, hold up. Should I share screen or Katie, do you want to jump on that?
I should be doing it, but okay.
Okay, sweet. So it's our second probleme, as the heading says. So we're given an array of sorted integers, and it's already sorted in ascending order. And we want to find 2 numbers such that they add up to a specific target number. So the function should return the indices of 2 numbers. That's something to keep in mind, indices versus positions, and we'll see how that works with our first test case maybe. And index 1 should be less than index 2. So as Bill said, it's always good to kind of just go over the question and then ask your interviewer or whoever you're doing it with, probably an interviewer, but just it's always good to ask any clarifying assumptions or if there are any assumptions you make or if there are any clarifications that you want clarified. So with that in mind, does anyone have any questions about this that you potentially want to ask if you're given this? Feel free to unmute yourself or type it in the chat. Okay, silence. Where? Oh, okay. Here we go. So what should we return if the array has two values, less than two values? Always great question to ask about edge cases or cases where it's empty. So you can assume that there are at least two values, and you can assume that there is always going to be one solution and exactly one solution. Eric asks, are there repeated numbers? Okay, Eric asks, are there repeated numbers? The answer is, for now, we can assume no, but that's always something good to think of. We can revisit that later, maybe as a follow-up question as to what would happen if there's repeated numbers. Okay, why does the third case return 1, 2? I think that's consistent. We'll see. Yes, Corwin gets it. It's because in this question, they want indexing to start at 1 instead of 0 because I guess they just want to trip people up. Okay, so I think we can hop onto the replit. Yeah, we can hop onto the replit now. And I'll drop in our first test case. Okay. So just going to make sure that that test case is visible. Sweet, we're chilling. Okay, so for our first test case, what we see is our input is this array, it's sorted, it has more than two values, there are no repeated values, and the target is 9. So 2 and 7 add up to 9, and the output here is 1, 2. So what that means is that in this question, they're asking us to assume that our indexing or positioning starts at 1. That's not a worry, we can always handle that. Okay, so another question that I had when I first saw this is, can you use the same number twice? So like, I guess if it was something like, if we had something along the lines of this as our input, if it was like 1, 2, and 3, would the output 0, 1, 1 be possible? And that's just an assumption. That's just a question I had. It depends on your interviewer, whatever they want to say. But for this one, for the purposes of this, we'll assume that you can't use the same number twice. So that would kind of be implied by saying that index 1 must be less than index 2. They can't be equal. Okay. So now that we have all those clarifications out of the way, we're clarified, like clarified butter, I guess. We can now think about our first super basic implementation. And I think it's always good to just get out what a brute force implementation would look like. So does anyone want to type that in the chat or unmute yourself potentially? What would like the least, yes, a double for loop. And so what we do is we just, yeah, a nested loop checking for every combination, 100%. What we've done is we'd have 2 for loops, and then we'd basically just check every possible combination. Now, what would the big O of that be? So if we were looking at every possible combination, what would the big O of that look like? Yeah, that would be n squared. Okay, so once you've gotten out your brute force implementation or just ideated it out, got out that brute force big O time complexity, we can now think about how we can improve on that. So n squared is our base, which means that we know that n squared is the brute force solution. So there's probably something that exists that's better than that. So maybe log n, n log n, or just O of n. So now, given that we have this sorted vector problem, would there be a way to do it in just a single pass? And if so, what would I want to keep track of? So are there any ideas about potentially doing this in one pass? And again, feel free to drop it in the chat or unmute yourself if you wish to. Okay, I don't see anything as of yet, but we're chilling like Antarctica, no worries. So is it something about the values being less than or greater than the target? So that's definitely a fact that could be useful. And yes, so that's definitely something to keep in mind for the solution. That's a good place to start. That like, if a number is maybe like greater than the target, we don't, that like that plus something couldn't possibly add up. Although, again, you do here have to think about negative numbers. So if there were negative numbers involved, then you'd have to be careful about that. For now, we'll just assume that there are no negatives, no zeros, none of that stuff. Can we use the fact that the values are in ascending order? Yes. And this is kind of like life hack or whatever. If the question says, given something, something, something that's sorted, that fact that it's sorted is probably going to be important. So I think, Eric, 2 pointers. So we could have 2 variables starting at the beginning and end and move them inwards. I really like where this is going. So potentially, what would you use? What like logic would you use to decide on moving inward? So like what's being said is we start off at the beginning and the end, and we kind of make our way inwards. So what that would do is, instead of like having 2 loops that just keep on going through and getting that n squared complexity, we just start at the beginning, at the end, and make our way in. So that would just reduce it to basically a single pass. So what logic would we use to move the pointers that we're having inwards? 2 comparisons. Okay, so what would we want to compare? Yeah, the sum of numbers in our target. Yes, absolutely. So at each step, yeah, absolutely. I think we have a solution worked out in the comments. Basically, what we're going to want to do is we're going to start at the beginning, at the end, and then based on the value of the sum that we have compared to the target sum, we're going to either move inwards or outwards. And I'm going to jump, sorry, I'm going to stay on the replit, but let's kind of step through our example to see how that could work. So for initially what we have is we have a target 9 and we have this array. So let's say we start at the beginning and at the end. So what we have is 2 plus 15, and 2 plus 15, that's 17, and 17 is greater than 9. So what that means is that we have a sum that is bigger than our target. So we're guaranteed that 2 plus 15 is not the answer, and we want to reduce that sum that we have. So the way to reduce the sum is to move our end pointer inside by 1. Does that make sense? So we jump from 15 to 11 because we want to decrease. Does that logic make sense? Okay. So again, what we're going to do next is we're going to add 2 and 11, and we're going to say that's 13, which is bigger than 9. And again, we want to decrease that sum. So we're going to move in again, and we're going to compare 2 and 7. And that's going to be equal to 9, and we're done. So here, there's basically, we're starting at the beginning, starting at the end, and that's all good. But what's our loop condition? Like, what should we think about while we're looping through the array such that we exit on time and don't just like loop infinitely or loop excessively? Are the rules between arrays and pointers the same between vectors and pointers? Okay, so this is, that's a good point. And when I say pointers, I just mean like the index. So we'll see that, but basically vectors have iterators, which are basically pointers, but for vectors, they'll go over that. That's and super lazy of me to say this, but it's beyond the scope of this of this exercise. I'll show you what I mean by 2 pointers in just a minute. But are we fairly clear on the intuition for why we're going to kind of like move our end pointer? Okay. So now let's look at our second example. And what we have here is 1 and 3, and I'm going to say target 5. And then this would be 2, and this would be 3. So when we first start off, we're going to have one index tracking the beginning and another index tracking the end. And I'm going to say, okay, so 1 plus 3 is 4, and 4 is less than 5. So I have to increase my sum. So to increase the sum, I'm going to move my beginning pointer because we want to access the bigger elements. And so we then look at 2 and 3, and that's equal to 5, and we'd be done. Oh God. Okay, we're chilling again. So given that intuition, I think we're ready to start coding this. So what I'm going to do is, okay, vector int res. I'm going to declare my 2 indexes that we're using to keep track. So small and big. And I'm going to say small is equal to 0 and big is equal to, numbers.size -1. Okay. And I'm also going to declare a variable called sum that we're just going to use to keep track of the sum at all points. Okay, so now we're going to have a while loop because we want to loop through the array. And what would the condition on this while loop look like? What are we thinking of so that we don't just loop forever and die miserably? Okay, so while sum is not equal to target, that's something we could do. Yes, so there's a question, will there always be a solution? And we can assume that we're guaranteed to have a solution. Okay, so the solution I had in mind did have while small is not equal to big, but you can also probably do while sum is not equal to target. So I'm gonna add in a comment over here. That would kind of change a few things in your implementation, but for now we're going to say while small is, I think less than big should work. Okay, so at each step, what we're going to do is, why is this underlined? Undeclared identifier by, it's 2021. We don't do that anymore. Okay, what we're going to say is sum is equal to numbers sub small plus numbers sub big. And now I'm going to write out a quick if, and we're going to use these conditions to do some stuff. Okay, so if sum is equal to target, we're done. Unfortunately, just commenting we're done doesn't actually solve it, so we're going to have to write some code. But what we just want to do is we're going to push our indices into the vector, and then we're going to jump out. So what we're going to say is res.pushback. Oh God, not that. Res.pushback small and res.pushback big. And return res. Now, for this case, assuming that like sum is equal to target, is that like implementation in the if correct? Like, is that correct or are we missing something? And I guess the phrasing of the question kind of gives it away. So I'm going to rephrase. What are we missing? Yes, that's a really good catch. We're missing the +1. So since our test cases have been given to us in such a way that we're not just like using the index strictly in a C++ way, we're using index +1. So if it's 2 and 7, the indexes are 0 and 1, but we want to return 1 and 2. So we're going to add 1 to both of those. That's a really good spot. Sorry, what are the res pushback? Oh yeah, no worries. Yeah, they're adding an element to the vector. So in C++, to add stuff to a vector, we use pushback. That I guess it pushes an element to the back. Okay, so that's that case. So now I guess we'll take the case when sum is less than target. So when sum is less than target, what do we want to do? When sum is less than target, it means that we want to increase sum. So what we're going to do is we're going to simply increment small. And then in our third case, we're not going to have enough of a sum. Like our sum is, our sum is too big. So we want to reduce the element sum. And what we're going to do, so for that purpose, what we're going to do is we're going to decrement big. And I think that should be it for our implementation. So we can add our test cases in here. So I'm going to say, just before I do that though, are there any questions on the implementation? Okay, I'm going to take that as a no. So let's see, test case 1. I'm going to say vector of ints, and I'm going to call it testy1 is, let's see. Okay. And toSum returns a vector of ints, so I'm going to say vector int res is toSum of testy, of testy1, in fact. Okay, and now, oh Lord, and target, my bad. And the target is 9. Okay, and now we want to print out our vector. So what we're going to do is simply print out res. And sadly, this doesn't work as we hope it would. So instead, we have to create a little loop and loop-de-doop through. So we're going to say for int I is 0, I less than res.size, I plus plus, and we are going to see out res sub I, and I'll add a comma maybe. And we'll do that. Okay, so now I'm going to go to main real quick. And, oh Lord, where's main? Oh, it's at the bottom, never mind. So we're going to test toSum. Okay, so I made the change to test toSum, and it has, did it show up in main? Let's see. Okay, yeah, it did. So I'm going to run that real quick, and it should print out 1, 2. Yeah, it did. So that worked as a first test. And now for our second test, we could probably do the other one that we mentioned. So I'm going to hop back into test toSum, and I'm going to add in this test case. So I'm going to say, I'm going to say a vector of ints test2 is this. The target is 5. So I'm going to say res is toSum of test2, and our target is the number 5. Okay. And now, yeah, so now the test should print. So I think it showed up on the screen share. Okay, so we're going to hop back into main. I don't think we have to change anything since we're just calling test2sum. And I'm going to run it again, and let's see how that works. Okay, 2, 3. So we're chilling. Sorted twosum. That's that. So yeah, I will hand it over to.
Okay, great. Before we move on, I totally forgot about this for the previous question, but we're going to pull difficulty and kind of the explanation how clear it was for this problem. I'm going to wait like 30 seconds here, but please fill out this poll, and we'll get on to the the third problem shortly. Okay, great. I think we can move on to the third problem.
Okay, so this is the third problem. We're given a sorted array nums, and we have to remove the duplicate in place such that the elements appear only once and return the new length. And you might wonder, what does in place mean? Well, the problem tells you that. It says, do not allocate extra space to another array or vector actually. You must do this by modifying the input array in place with all of 1 extra memory. So how do we do this? Well, you might think, well, like we can say what all the elements that we have read and compare that to the new ones that we haven't read and like delete them. But that would be a lot of big goes, because remember that deleting elements except the end of it would be O of n. So deleting a lot of them would be not ideal. So do we have any ideas to solve it without deleting it? The hint would be using the idea that Arjun just used in his problem. So what if we have 2 indexes? What if we have 2 pointers to the array? How we do that? ideas. Okay, well, if you look at the problem closely, it says that the array is already sorted. And with that information given, we know that the numbers will be, elements that are the same will be will be aligned. So then say if I have an array of 00105, it'll be sorted to 00015. So then I can just skip the zeros and just count the unique ones. So what if we have 2 pointers? Say I have an array of 0116. I have 2 pointers and one of them is fast and only points to the unique elements in the vector, and then the other one is slow and traverses through the whole vector, right? So then, so the first one is 0 and the second one is 1. So they're unique. So then I move both pointers to the next element, right? And then I look at 1. 1 is not unique, right? I have 1 and I have 1. So I move on. And then I check the next one, which is also a 1. So it's not unique. So my my fast pointer doesn't move because my fast pointer only points to the thing that is unique, right? And then I check number 6, index 4, number 6, and it's unique. So I move my pointer there. That's the general idea, right? So if we were to code this, then then it would be, so we have, say our J pointer is our fast one. We can just loop through the whole thing. Right, and if I have the first element, or if they are not equal, that's the only condition that I will not, my neighbor is not the same, then that's the only condition that I will move my pointer. And since my fast pointer only increments when I encounter a unique element, I can just return J. And that would be the new length for the element. Okay, so we can write our test cases here. So our first test case, if we go back, it's 112. So if we do that, then it should return the length of 2 because we have 1 that's unique and a 2 that's also unique. So let's test that. Forgot the semicolon. Okay, so sir returns 1. Recall that sir returns 0 if it's not correct, and 1 if it's correct. And we receive the 1, that means that it is correct. So let's test our next test case, which is 00111 2 3 4. So we have 0 to 4, so that should return 5. Okay, so it's 1 and 1. So that means it's also correct. And you can just add in your own test cases because sometimes they ask you to test it yourself. So you can add in test cases you think might not work and just test it yourself. So in the case where we have an array of all the same elements, it should return only 1. And if you run the program, it would work, right? We have, they returned once. So that means that it worked. So moving on.
Poll.
All right, let's have the poll.
Oh, okay. And then we'll launch a poll again. So let us know how you found that question and how you found the explanation.
Okay, so there are people who didn't really understand. So let's go back. Okay, so we have 2 pointers, right? We have a fast one and a slow one. They're looking at my array. And then my slow pointer is the one that traverses through the whole array. It looks at every element. And if my element are not the same, then my fast pointer goes to that place. If they are the same, that means that the element is not unique. Then I stay where I stare at where I am. So then if I look at it, I have 2 pointers, one slow, one fast. And then since 0 is different from 1, I move on. And then 1 is not different from 1, so only my slow pointer increments. And 1 is still not different from 1, so my slow pointer is still increments. But 1 is different from 6. That's why when I check number 6, I also move my fast pointer there. Is that clear enough?
Okay, well, we got about 12 minutes, but we're going to introduce a successive question. So problem number 4. So let's just go through it for now, and then, reversing a string. Okay, it sounds pretty similar to reversing a linked list. You'll probably need to know that as well for your technical interviews. But I guess our constraint here is that we have to do it in place. So that just means that we can't create an additional array just to house our reversed list. Doing it in place gives us a little constraint, and I mean, that gives us a pretty good idea of what we need to do. If a technical interview question comes up with like this, then should give you some insight on how to do the question. So when I think of O of 1 extra memory, that just means like, oh, then I can have a temp variable. That should be the first thing you think of. Like, okay, well, I'm not allowed to like create a different, like a whole separate array, but I probably can just, house a specific temp variable for me to switch around. So looking at this question, so first step is to read the question and then restate the question. So I'll give you about 20 seconds, hopefully 30 seconds to read the question. And then afterwards, I'll be, going through it myself. So. Time's up. I think it's 20 seconds flew really fast, didn't it? Okay, so basically what this question's asking us to do is, like I said before, reversing a string. Let's think about the S cases. So as previous, so what should we be thinking of when we're trying to do this problem? Drop it in the chat. You can, speak out loud, but I doubt anybody wants to do it here. But I would really appreciate it if someone just tells me, I don't understand anything. Yes, I like that. So what if we do get an empty string? So this is a great question to ask. If we get an empty string, I'll just, in this case, I'll just be like, okay, well, just don't return anything, or just like exit early. So just turn 0. So, and then also like, base case, if we had a length of 1, if we had a string of length of 1, or I guess in this case, it would be a car array of length of 1, then we can also exit early and just return the single character. In this case, as you can see on the right, that we have a vector of cars, very similar to a car array. It's just a slight notation difference, but just know that instantiating a vector is going to be a little bit different from a car array. Regardless, so anything else that I need to be watching out for? So in this case, when I think of a string, I always think, you can have odd and even length strings. So to think about this later, then when I implement my algorithm, I have to make sure that when I check my, by implementing my test cases that I make up myself, I'll try to do it on both even and odd strings, because like, I guess in this case, it doesn't really matter, but maybe like odd strings, if we have the middle, then maybe the middle will break, or, doesn't go over it. In this case, it shouldn't matter, just because if we're reversing a string, the middle character doesn't get changed in the first place. And then if it's even, then it will get changed. So you always have to keep track of that in the future. Okay, let's switch over to Replit. Awesome. Okay, let's see. Pull up. Put it at the bottom. Oh, sorry for not pasting the question. Do you think someone else can do that for me as I go through the solution? Okay. So when I look at this question, I think of 2 different ways I can do this. Does anybody have a hint that they can give me to maybe, tell me what I should be doing maybe firsthand? So we did the 2-pointer rule. Oh, we're starting at the end of the game. Yeah, exactly. So we can use the 2-pointer rule, and that is, we taught you before, so we can try that. But is there another way that we can try this? I actually didn't think of the 2-pointer way the first time. I actually thought of a different way. Like 10 seconds, and I guess I'll tell you my thought. Okay, there's nothing, so I'll just go on and talk out loud. But I initially thought, okay, I'll just use a for loop, but I'm only going to iterate at the beginning, or I guess halfway to the for loop, right? Because if we're going to have maybe like 10 character length, so that I only have to go through 5 when I'm switching, so I can switch from 1 and 10, I guess 0 and 9 in our case, because 0, 9, and then 1 and 8, 2, 7, and so on, right? We only have to do that. So initially, this is basically the same approach as a as 2-pointer, but except I'm not using pointers, I'm just using a for loop. So get that out of the way. But thanks to Aiden, we're going to use the 2-pointer rule just to continue on with our lesson, just like from the previous session. Okay, so first things first, I check the return signature. As you can see here, we're passing in this not by value. We're passing this so we can directly modify it. So it looks good to me. Okay, so let's see. Oh, sorry, thank you for calling that. Okay, so we need to have the length of the string, car, right? So let's just call int size equals, just call this on the vector itself. And then we also want, a temporary character, right? Because we're going to be modifying it in place. Therefore, we need a temp character just to store if we were going to do 2-pointer. So let's call temp. How about that? And then what else do we need? So we need, our beginning and our end, right? Just like what the 2-pointer was. So let's do the 2-pointer. So let's do int. Just call it int. equals 0. So that's going to be our first position. And then we're going to have int n equals side branch, right? Because we're going to always one left. Okay, 2-pointer. Let's do our while loop. So this is our important thing. So we're going to be iterating this as long as the smaller as the beginning is less than n, because we don't want to be crossing over multiple times, and that just gives us the same exact array again, wouldn't it? So that's not what we want. So let's go beginning is less than n. Okay, so can anyone tell me what should be in this for loop? I mean, in this while loop, sorry. So we should be setting each character, right? So as the diagram from the slide before, if we're going to switch it, we probably want to make a copy of either of the ones that we're going to be doing mid switching, just in case when we do switch it, then we can directly do the temp variable and set it equal to the other variable that we're going to be doing. So I guess to illustrate this, we can just say like, okay, well, I'll just let my temp variable be the beginning. So then when we switch it, then beginning will hold the new end. It'll be holding end, but then the temp variable will be holding beginning, so the end can take on that value. That seems kind of confusing. So if you do need a clarification, I would be more than willing to, I guess not whiteboard it, but show it through the replit. Anything? If not, okay. Feel free to interrupt me as always, but I'll just keep on coming on. So we can directly index it this. So let's go to the beginning. So s of beginning is temp, and then we're going to do s of begin equals s of end. And then s of end equals s of begin. Okay, so are we done? Still look good? Exactly. So we have to increment our beginning and end, just because, if we don't, then we're going to be stuck in this while loop forever, because beginning is always going to be less than end every time. So let's do begin, let's do 1. Wait, actually, can we do plus equal? I think we can. Okay. Sounds good. Does this make sense? It does make sense. Then let's go on to testing this. So what we have here? I obviously I code this up, but maybe I'm just completely wrong. You never know. Okay, so someone give me a string that they want me to reverse. Obviously here it says AAB, but I think we can be a little bit more creative than that. Try to give me some stuff that you think could not handle a test case. So in this case, I didn't actually handle, if the int size is 0 or the vector size is 0. So that might bite me in the butt later on. So be sure. Okay, UCLA. UCLA it is. We like your school spirit. Okay. I can't believe I just put UCLA on. Okay. So UCLA, let's print it out in the first for loop, and then we're going to be calling our reverse string on it, just because reverse string will modify in place. I guess with memory, so we don't actually have to create a copy of it, because it won't return anything in this case. Let's do A, right? Now again, we're going to do, also, if you don't know auto I, it's really nice. In the new C++ standard, it automatically knows what variable type I will be from A. So I don't know if Malberg will let you do this or Notchenberg, but this is also very nice in the future when you get out of undergrad. I guess like underclass. I don't know what the lower classes. Okay. So EC out as always. Let's do I again, and then we're going to be doing. I guess we don't have to do. Let's just not do new line. New line afterwards. Good. Okay. So this works. Test row. Okay. This is wrong. So what did I do wrong? Oh, sorry, I think this is okay. This is 4. Maybe I didn't do anything wrong. But basically what AF4 means that I'm going to be, creating a variable A, like creating a vector of car A, and I'm going to get, it's going to be 4, like I'm going to give it 4 indices. Okay, so did anybody catch my mistake? Oh, wait, sorry, what does 4A auto A I of A do? Okay, so basically auto is a part of the new C++ standard, but I'm not sure if Smallbird's letting you use that. It will tell you, it will infer basically the variable type of I when you iterate, and it automatically iterates through all of A, as you can see here. I recommend checking out the documentation for on the C++ website, but this is just an easy way to iterate through without having to do like int I equals 0, I less than, I dot begin. So, okay, so syntactic sugar, yes, I think I can agree with that. Okay, so the swap was done incorrectly, correct? Okay, so let's do, so where is it wrong? Oh, it's over here. Right, so thank you for the catch. Let's run this again. Sounds good, looks good to me. But obviously I didn't code any test cases, so can somebody give me a function breaking test case so I will be humiliated on this nice workshop. I should probably. Okay, so nobody wants to humiliate me. Thank you very much. A single letter, great. Okay, let's change this to 1 and let's just do A. How about that? Don't think A will do anything just because I don't actually even go in the while loop because end will be less than begin because end will be 1 minus 1 is 0, and then temp begin is also 0, so we won't even go in the while loop in this case. Thank you for saving my face and not doing anything. So this will be the end of this question. We're going to start the poll real soon, but does anybody have any questions for this particular question? Problem? I don't know, I keep on saying question. Please voice them right now. And if you want to know more about this for loop, like the syntactic sugar, like Sarthik said, don't worry about it. You can always look it up. It's pretty nice. So, not directly relevant to what we're learning right now.
Okay, great. The poll is launched, so please fill that out.
Also, just to reiterate, I didn't personally put in, if we were passing in like an empty vector, but be sure to do so in the future when you're doing your technical interview, just because, you're going to see, you'll be like, didn't write enough unit tests, and be sure to test the empty vector as well. Like then you'll be like, oh, I caught my mistake, and then you could fix it really fast. Show how responsible you are, obviously. In the for loop, would you have to check if the size is odd or even? So in this case, we don't, just because if it ended up like, if we're switching and then it ended up being the same, that means it's an even vector and then we would already have been switching it. If it's an odd one, then we don't need to switch the middle index in the first place, right? So in this case, it doesn't matter. But in the future, it's always good to test out odd and even length when you're giving a string question, just to see if your inputs differ. Sounds good? Okay, we're going to wrap it up and give the stage back to Katie.
Okay, so as you can probably tell, of all the problems that we did, many of them could be solved by having two pointers / iterators / variables by having them, right? So when do you use this two pointer technique? You use it when you're dealing with array / vector problems that deal with two elements in an array / vector that satisfies a certain condition. So in Arjun's case, it's element 1 plus element 2 would be equal to the specified sum. In my case, it would be that it is unique. And for Anna's case, it would be to swap, right? The front and the end. So when you're dealing with an array problem and they ask you about like 2 elements and they have a certain condition, although it might be a little vague and you can't really think of a problem, remember to keep this 2-pointer technique in mind because it will probably help you. Congrats on completing. You now can solve probably a lot of vector problems, and remember to fill the feedback form out. Thanks for coming, guys.
If you have any questions,